Hey, good morning. Welcome to another morning coffee with Trevor. I'm your host, Trevor Matthews. And once again, thank you for everyone who joins and participates and shares their knowledge because it's super helpful to me. And I really appreciate all the feedback and the comments. Hey, Aaron, how you doing?
Morning.
Hey, Joel, Noah, Donald, George, what's happening?
Hey, morning, Trevor.
Yeah, well, thanks for joining again. Today, we're going to probably get into TEVs. But before that, I would just want to thank everyone for taking the time to spend with me, learn a little bit, share a little bit of knowledge. And I really appreciate all the support. I've been working real hard for the last 5 months, starting to build Refrigeration Mentor, my brand, try to grow it to really reach more technicians out there because I really want to help serve the refrigeration industry and really help technicians get to the next level in their career, to be a little bit better each day, feel a little bit more confident, a little bit more effective with what they do at their job, to help serve their customers. Because at the end of the day, when you feel like you accomplished something and you did a great job, that you go home and you feel proud of the work you did that day. Even if it's a 10 or 12-hour day and you're worn and tired out, you still will feel like you did a great job when you're serving your customers. So what I want to ask from everyone, if you can share some of this content with other people, other technicians, people that you think will find value in the stuff that I'm sharing, that will really help grow my brand, grow Refrigeration Mentor, and really help me reach more technicians out there. So I want to thank all of you who have been doing that and continue to do that, because that means a lot to me. Everyone have a coffee this morning that they're enjoying, or a drink at, Aaron, you don't let me down on that one, eh? Perfect. And so we'll get into, anybody have any questions before we get started? How their morning's going? Well, this week I've been doing a lot of trainings. I've done quite a few so far. It's only Wednesday, so I'm pretty happy with that. It means I'm getting some knowledge out there. I'm sharing some value with others, which is fantastic. And today I think we'll go through some TEV information. There's a lot to know about thermostatic expansion valves, or thermal expansion valves, some people call it TEV, TXV. Metering device, valves. There's a lot of different names that people use, but there's so much to know. Like, once again, it's another device, a component in a system that I thought I knew a lot about until I started training about metering device and really understanding that at a deep level. And I learned a lot of my stuff from a guy named Andre Patno, one of my mentors. He's just a wealth of knowledge. This guy's a pioneer in the refrigeration manufacturing industry. And back in 1994, he wrote this TEV guide for Alco. So at the time in here in North America, it was called Alco. It's still called Alco in Europe, in the rest of the world, I believe. But it was Alco at the time. That's who he worked for. And he built this guide. And it's actually like a 26, 27-page guide on thermostatic expansion valve, TXVs. So that is a lot of information, 26 pages of different things. And over the years, I troubleshooted TX valves, I replaced them, and there's for sure times that I misdiagnosed TX valves, thinking it's a TX valve, replacing one, and then not fixing the problem. I've actually misadjusted them before, not knowing that the system's low on gas, the rack is low on gas, and I should open up the valve, and readjust it, and nothing happens. I've done that before, and then go to find out that there's no gas in the rack, and just jumping ahead, not taking those steps that I talked about, those sequence of operations or troubleshooting steps where you're doing a checklist to make sure you're checking everything before you start changing anything or adjusting anything. But in what I've learned after I started training on metering devices, that there's a lot to know, and there's still so much for me to know on them, like difference between like a balanced port valve and a conventional valve. and it's just really the range. That's the way I think of it, the range of it, and, really the capacity. But you'll see in the refrigeration and the larger applications, you're going to see more of the balanced port design. And then when you're into refrigeration applications, you're going to see more external valves, external equalizing valves and internal equalizing valves. And people ask me, well, what's the difference? Really, it's the amount of pressure drop across the evaporator coil. So if you have a distributor in a coil, you will have external equalizing valve, because you need to, inside the coil, it's multi-circuit coil, that's what they're called. And there could be different lengths of coil through there. And so at the end of it, if you have a big pressure drop, you need something to tell the valve what the pressure drop is. So that valve, that gas charge, that bulb, that's the opening force, tells the valve what it should be at, where it should be, how much closing force should be on that valve. And when you start to understand these valves at a deeper level and understand the different gas charge they can affect, because the gas charge inside that bulb, if it's a higher pressure gas in there, it's going to push the valve open at a different rate than a lower gas charge. And it's like, well, why do I need to know that? Well, there's lots of gas retrofits out there. You could buy a valve that has the wrong head on it. So the power element, which consists of, the capillary tube, the bulb, and the head itself with the diaphragm in it. And there is definitely times that I've seen the wrong bulb charge on there. It still worked somewhat, but if it starts running into issues, then you need to get the right parts on there. And the two biggest things that you will see is that you either have high superheat, you're starving your coil, or low superheat and you're flooding the compressor. And there's so many different things to look for. It's not just, okay, well, maybe it's the valve is closed off, the spring is a closing force, so the spring is pushed in too far or pushed up against the diaphragm too far. Well, there's way more than that. It could be lots of different things. Like flash gas is a big one. If you don't have a sight glass, how do you know how much gas is at your TX valve? Well, you need to check subcooling at the TX valve and understand, well, what's the temperature there? What's the pressure there? And you check, do you even have any subcooling? Because flash gas can happen many different reasons. You could be low in gas. It could be, ambient outside. You can have condenser pressure issues. So condenser fans banging on, banging off. You can have uninsulated liquid lines. All these different things can have flash gas. And really what flash gas is like little bubbles, that impede on the pin that opens up. So you have that bulb pushing on the diaphragm, so the pressure from the bulb, as that suction line warms up, the gas that's in that bulb, or whatever charge it is, it makes the pressure go down, push on the diaphragm and open up. So as that's opening up, if you have little balls, like little pockets of gas going in there, it impedes on the flow, and so it starts to starve that evaporator. So flash gas is real bad. So you need to figure out what's causing that. Is it low on charge, like I said? Is it a condenser fan banging on and off? Is it low head pressure? Whatever it is, you need to figure that stuff out. And it takes time. It takes time to figure that out. The other things that that could cause high superheats, restrictions. It's another big one. You could have a filter dryer starting to plug up. You could have a kink in the liquid line. You could also have an issue in the condenser. I've seen that before. I've had people call me up, Trevor, this is super weird. I got a cold liquid line and a warm suction line. It should be opposite. I should have a warm liquid line, cold suction. Well, really, there was a restriction in the condenser. It can happen. You can get a restriction in the condenser. So things that you don't really think of, that you need to think outside the box, critically think sometimes. You can have a loss of charge in that element. Right, that bulb. If that bulb loses its charge or starts to lose its charge, if it has a rub through or something, well, that's your opening force. It's pushing on that diaphragm to open up that little pin and let refrigerant through to fill, to satisfy that evaporator. So that could be an issue. Piping design could be another issue. Maybe you have the wrong size valve, wrong size liquid line. There's so many different things. Adjustment. You could adjust the TX in inappropriately or not correct. And these are the different things you really want to look at. You know, one of the things that, once again, I see this multiple times over the last few chats, is that, you know, manufacturer equipment that come in, I used to think, well, I spend so much money on this equipment, you know, research and development, and oh, the valve, it can't be the valve, like it must be the right valve. I've seen it before where the wrong valve was installed on a case. And especially if it's an older store, you don't know how many other techs worked on that equipment. So you need to go in as a technician and look and verify, is that the right capacity valve for that specific evaporator, right? Because if it is undersized, you're going to starve that coil. If it's oversized, you could flood that coil. So these are the different things you need to look for, especially when you're having issues. And this should be done before you even start adjusting it. Another thing for a high superheat could be that solenoid valve. Solenoid valve might not be opening up or working erratically. It might not have the proper MOPD across it, so the maximum operating pressure differential. And I've seen this, and I've read it in one of Sporland's retrofit guide. It's a great guide. I would highly recommend taking a look at it. When you're going from 404 to 448, 449, you need to check the sizing of those solenoids, because it maybe you might have that 1 PSID, that differential, the MOPD across the valve from 404, but when you retrofit to 407A, F, 448, 449, you might not have that differential. It needs to open up, and you may have erratic issues. So if you're doing a retrofit, that's something that you need to look at. Will it work? I've talked to lots of contractors who did that type of retrofit, and they say everything has been fine, but it's something you need to look for, right? Contamination in system. Another thing, like I said, you can have a blocked filter dryer, or you could have something plugging up the valve itself. You know, maybe the screen is dirty. Maybe you need to check the screen. There's lots of different things that you want to look for, and it takes time. You know, and sometimes when you're in a rush and you have 10 calls holding, you know, and you're kind of stressing to try to get everything out, and then you at 5 o'clock you got to go to a kid's soccer game, or you got an event, and you're trying to get all these calls, you could be missing some stuff, right? So you just got to take your time, take a breather, and try to fix the problem at hand, you know, at that point. You know what I mean? Not thinking about the calls that you were on, or the calls you're going to be going to. Think about and work on the call you're working on, so you keep your head clear and you understand what you're working on, because I've done it before, once again, where I'm thinking about 3 or 4 other jobs, not focus on what I'm working on at hand, and then I cause more issues at the site that I'm working on than the sites that I'm thinking about, right? So, yeah, wrong charge power element, undersized compressor, oversized evaporator. So those are like the oversized evaporator. Like if it's way oversized, you would be starving it, because then that valve would be undersized for the system, for that evaporator. And these are different things in this book that I read and learned from over the years from some of the valve experts. And I still got lots to learn. Like I said, another great resource is Jamie Kitchen from Danfoss. This guy's an expert on valves. He has lots of videos on YouTube. I would check those ones out. Very smart. He's huge on education as well, on sharing his knowledge. So if you don't know who he is, check Jamie Kitchen from Danfoss out, because he shares a lot of this knowledge and education. So low superheat. Anybody have any questions? Again, I'm talking a lot here and enjoying my coffee. Give me a coffee break. How's those exams preparation coming, Aaron?
Pretty good. We're finishing up air conditioning class, and actually we're talking about everything you're talking about here with the TXVs and the distributors and the superheat and subcooling and all these things, wrapping it up. We're going to do some static pressure measurements today, and they're getting pretty good. Students are getting pretty good. We're doing these experiments on our lab equipment and equipment around the school. So it's cool. They get to to see some equipment that's in working systems, not just a furnace sitting in the corner of a lab somewhere. So it's going really good. Thanks.
Yeah, no, that's awesome. And that's actually working on live equipment, which is the best experience to have when you have an expert with you. You know what I mean? A journeyman or experienced technician with you when you can work on that actual equipment that's running there that could be issues, could not be servicing. Because in the lab environment, it's quite a bit different, you know, because I've worked in lots of different labs and it's great setups for sure, but there's just still that little bit of difference when you're working on that actual equipment, you know, cooling somebody or cooling product, which is pretty cool.
Can I
go ahead, please?
I'd say I'm terrible sometimes at remembering all the different, little aspects to sometimes valves, whatever it is. So I don't know how long ago it was, a few years ago, I started keeping PDFs either in a cloud service or in a folder. And I found Sportland has really good, like you mentioned, some really good PDFs on valves. Best. And I found one, it must be like 5 or 6 pages. And it has a whole breakdown on diagnostics, even on all different valves that they have. And so I found that pretty helpful. So I keep that in paper form and on a cloud drive just so that I can access it.
Yeah, and that's so important. Thanks for sharing that, because when I had my van or my truck, I used to have crates of books. Like I'd have a whole shelf of technical manuals just in case. But one thing that I'm remembering back now is that I didn't take them out enough, to be honest. They sat in my truck a lot more than what I should have reviewed. I only really pulled them out when I didn't really know about a valve or we didn't have a phone really to store anything on. So I highly recommend that. You should have specific folders and kind of organize, unless you know how to search. You have a certain search method, but have them broken down in compressors and then metering devices. And yeah, Sportland has some amazing literature. Once again, it takes a little bit to find it, but you need to practice at that, finding this literature. Because I've learned that even from when I worked at Emerson. There's just so much information, it's hard to find sometimes. You know, even when I worked for them, it took me a while to find information, and I became very resourceful over years and years of practice to find that specific information, as well as even other manufacturers, like looking for Danfoss stuff or bits or Sportland stuff. It takes a while. It's not super easy. Even though it's out there, they just got such big libraries of information and content. So it takes a little bit. And then there's so much information on each specific component, like TX valves. They'll have dozens and dozens of manuals because each valve works a little bit differently. Like you'll have industrial valve to a commercial valve to a residential valve. Yes, they're metering devices, but there's different internals on them. They could have bleed ports. They could have check valves in them. They could have, they could be take aparts where you pull them all apart, like their Q1. And this is no different from the Danfoss ones or the Emerson ones. So it's all this little information that you need to learn over time, and then assess the equipment you're working on, because they'll have differences. There's different uniquenesses. There's no different than any component out there. Yes, it's a TX valve, a metering device, a TEV, but different manufacturers will have like different ratings. You don't want to overheat the valve. I've seen that so many times. I've overheated many valves. You need to be wrapping them, because inside them, you can start damage them, right? You can damage that external equalizing port. Some of them have like little gaskets inside them, and you can wear the gasket out. Some of them, I've even seen like the bottoms of them drop right out because, if you heat them over 250, like some of them will have solder inside them, and where if you get it hotter than that, it'll start to, unbraze it. And I've seen TX valve bottom drop right out when you overheat them. So it's important to understand the equipment you're working on. So for low superheat, there's so many different things that can cause low superheat. Like adjustment is one thing. It could be set too low. System could be overcharged or overcharged with refrigerant and or oil. So if you have high subcooling, TXVs, they are to meter the amount of refrigerant in there. But if you have a lot of pressure because there's pressure differentials on them, a lot of pressure coming in. You could cause low superheat. Wrong bulb and equalizer line location. That's a big one. You know, it took me a while to figure that one out, but that equalizer line needs to be downstream of the bulb. So that bulb is getting the right information, and that equalizer can put that pressure underneath for the closing force. If you cap the external equalizer line, that's a closing force, right? So if it's capped, how can the valve close, right? Or if it's put in the wrong location, it's a potential chance of flooding. I've seen this lots of times where on headers, you know, you have a little 1/4-inch tube at the top of the header and the suction lines at the bottom, and then someone puts that to the external equalizer. That's not checking all the pressure. You're not getting all the pressure from the whole coil, so that could potentially cause low superheat. Frosted or frozen coil, system contamination, like you could have copper jammed in that pin, open up. So, and there's other things that could cause it that you wouldn't think of, like uneven loading of the coil itself. So the airflow going across the coil, say you have the wrong fan blade on, or the fan blade's backwards, or you don't have the proper airflow across that coil, you know, that could cause it. You know, plugged honeycombs and cases. It could be a dirty coil. It could be fans out. There's so many different things. Distributor not pointing in the right direction. You know, even uneven distribution from those feeds. You know, if you look at any of the manufacturers, they really want you pointing them up or down, so you're getting full liquid flow to all of them, so it get a good feed to all the different points of that evaporator. And if those ones are kinked, you could run into issues. Solenoid valves, you know, jammed open, you know, and that could lead to other situations as well. But if the system shuts down and the solenoid's open and the evaporator fills right up with refrigerant and a compressor starts up, you get a flooded start, but also you'll get low superheat as well. So all these different things we need to think about. And it takes time. You're not going to learn this overnight. Like I'm still learning it, you know, and I've been teaching this for years, and I'm still learning about them all the time. And you just really need to refresh sometimes too, because as a technician, day in, day out, it's going to be different. There could be days that you're just washing out cases or cleaning drains. There could be other days you're doing, you know, changing compressors out or doing whatever, you know, cleaning coils. Because a lot of the stuff year over year I've seen when I was a technician, I used to think like going to a call, it's this big, massive issue. But most of the time, it was just really something simple. Like the people left the door open of the walking box, or the coil's dirty, you know, the condenser's dirty, or fans out, you know what I mean? And it's not, I used to think, oh, well, the compressor has to be dead, or the system's out of gas, you know, or there's no oil in the system, you know, these big, massive issues. But a lot of the times it's not that, you know. So that's why I learned over the years not to overwhelm myself before I got to a call. Really kind of think about the call when I got there. And I used to rush the calls, you know, to make up for my confidence, you know what I mean? My self-confidence, where like I didn't feel like I knew what I was doing for many years. You know, like I would go out and I would do my job, but there's lots of jobs during that week. But like, oh, did I fix that or did I not? Until over the years, I got more experience, and I didn't start to rush through a job to make up that. I got to a job when I got there, and then I took that job at hand that I was on, took all the information, you know, asked the customer, asked the manager of that area, and asked some questions. And then once again, did my research of the store, like go and find out what's going on. Is this the case that is the issue? Okay. Was there, you know, and is the fans working? Is the lights on? Is there airflow? You know, are the pipes cold or warm? And did this stuff and then these like little checklists just to make sure that I assessed everything. But this took years to get to that point. It took years before I started doing that stuff, because I was just, you know, a lot of the time just shooting by the hip and just go and say, okay, this is the problem. Okay, let's get out my gauges, get out all my tools before I really did an assessment of the site and really understand. There was definitely times I was working on equipment that they told me is the problem equipment. It wasn't even the equipment. I had to put my stuff on, get it up and ready, and all of a sudden this unit starts right back up. Like, what is going on? I thought they told me this is not the piece of equipment working, but they didn't know it was 2 other pieces of equipment down, and this happens. So that's why you need to do an assessment of what's going on before you just start throwing your tools on, so you get a better understanding of what you're working on. Oh, that's all right. That is all right. Anybody have any stories about valves they want to share with everyone? So I will throw some of the valve literature I know of online in the links or descriptions of wherever the video is on YouTube for sure. And so you guys can find it, make it easier for you to find the information you need, because when you understand where to find the information and the resources, it's going to make your job so much easier. Right? It does. Yes, it takes time to read. And I know a lot of us don't want to read the manuals. I was there for many years, but I've learned the value of reading the manuals from start to finish. And what you'll notice when you start doing this over time, most of the manuals will start saying the same things. And you're going to start seeing repetitive things from the different manufacturers. And you're going to be able to start flying and reading through the manuals a lot quicker. And then over time, you're not going to really have to go to the manuals. You're going to understand, have that experience, and feel confident when you're troubleshooting something like a valve. And you're going to be like, okay, I'm not adjusting the valve until I know the coil's clean. I got enough liquid. The subcooling's good. There's no bubbles in the sight glass. All these different things you're going to check before you start adjusting things. That was one of the biggest things I think every job that I was hired on, well, almost all of them, they were like, well, one of the biggest issues we have is technicians going and adjusting valves and not fixing the problem. Because you go in, you open up the valve, all of a sudden, okay, I got more cooling. I opened the valve up. But maybe it's a plug screen, it's partially plug screen. So you open up and you get a little bit more flow going through. Now your coil's back. And then really, when someone goes there and cleans that screen out, and all of a sudden now it's flooding back. So these are different things that you need to look at and take into account. Don't just go and adjust the valve. Assess the site. Is the airflow good? Is the static pressure good? Is all these different things good before you start adjusting things? And there's so much more to it. Like we're just brushing the top of it, valves, because those specific valves you're working at, you need to understand there's more and more valves coming out there on the market, different refrigerant, different power elements, and it's the new valves are now electronic valves. You're going to see so many electronic valves. That's the way the industry is going. And you're going to need to learn those as well. Going forward, you're going to need to understand the equipment you're working on. But make sure whenever you're working on a valve, you understand how that specific one works. It's installed. For an example, like every case that I've installed starting out never had insulation on the bulb. Never. So I didn't think you needed insulate the bulb, but you really should be insulating the bulbs. And I've seen issues happening and not recognize it because the bulb wasn't insulated. Infiltration of air, diffusers blowing hot air down onto a case, or in air handler where there's air coming through one of the panels because it's not sealed properly, blowing on the bulb, causing erratic operations. So these are things that you'll pick up and learn over time, but that bulb should be insulated. You talk to any manufacturer, it should really be insulated. And then I know the case manufacturer will say, well, that's in the airflow, so that it shouldn't affect it, but I've seen it done affect it, you know. So if you run into that issue, insulate the bulb so you know exactly what that suction line temperature is, so you don't have any interference. Awesome. Hopefully there was a thing or two you learned today. Really thank and appreciate everyone's comments and sharing. And once again, hopefully I'll see you again tomorrow. Have a fantastic day, and let's get a conversation going.